The code shown is a recursive function that takes an input list and returns the sum of all elements in it. Basically, recursion means making code simpler or easier to understand with the use of loop. The code starts by initializing a variable called lst to be an empty list, then creates a new instance of list recursion with lst as its argument. This is done so when you call the function, it will create another copy of itself recursively, with each iteration adding one more element to the input list until there are no more elements left. So on the first line of our code, which is on line 2, it means that this object state is set up based on what was passed on to it. So in this case, it's an empty list. So on next function, our next function, it defines how this object should initialize itself when created from outside of its class definition. So in this case, we are setting on the line self._sum_list _recursive self.lst as its default behavior. So on the third function, it would return 0 because there are no items in the input list and therefore nothing to do at all, since we're already finished iterating through everything else in our recursive loop. And next, we have the if statement, where we have our data structure, which is the list, and inside the list is our integers 1, 3, 5, 7, 9, which give us an output of 25 when we sum all of these integers.
Data structure in the code above is a list. A list contains or stores sequence of numbers that are used in the program.
The code above is an example of OOP in Python. It defines a class list recursion that has an instance variable list and a method sumList. The init method is used to initialize the list instance variable, which is a list of integers passed as an argument to the class constructor. The sumList method uses recursion to calculate the sum of all the elements in the list. It calls a private method sumList recursive with the instance variable list as an argument. This private method is a recursive function that keeps adding the first element of the list to the result of the recursive call on the rest of the list until there are no elements left. Finally, the code creates an instance of the list recursion class with a list of integers. It calls the sumList method on it, and it prints the sum of the list.